All right, welcome to another deep dive. This time, we're taking a look at something I think a lot of you have been asking about,
Hmm.
and that's how to make 3D JavaScript specifically for open source physics simulations.
Okay.
Now, this actually involves a program that you might not expect. That's SketchUp.
Interesting.
Yeah, the one architects use.
Okay.
So it's kind of cool how we're going to be taking something from, the design world and using it in the physics world.
Yeah, it's really taking like design and breathing life into it, so to speak.
Exactly, making it interactive.
Yeah.
So first step, obviously, we got to get SketchUp, get it installed, and we need to find ourselves a 3D model.
Okay.
The example they use in the source material here is an airplane model, which I think is,
Perfect.
perfect to visualize.
Yeah.
So we've got SketchUp, we've got our airplane model. What do we do next?
Well, you have to do a little bit of model surgery, if you will.
Oh,
So we need to adjust the model's origin point and make sure that it's aligned with the x-axis. This is to ensure that it'll work well with the Easy JavaScript Modeling Tool, or EJSS, as we'll call it.
okay.
Think of EJSS as the bridge between your 3D model and the physics simulation that you want to create.
Right. So it's like we're translating between languages.
Exactly.
I got to make sure they can talk to each other.
Got it.
But I think a good question here is like, why are we going through the trouble of using 3D models in physics simulations?
Yeah, well, let's be honest. If you're learning about, say, how a plane flies, just by reading a textbook, it's pretty dry, right?
Yeah, for sure.
But now imagine being able to manipulate a 3D model of that plane,
Wow.
seeing how lift and drag work in real time.
That's cool.
Like, that's when physics comes alive, right?
Yeah, it's like the difference between reading about music and actually playing an instrument.
Totally.
You get a much better understanding.
Yeah, and the beauty of open source physics is that it gives us these tools that allow anyone, for free, to create these
Right.
really powerful learning experiences.
Amazing. So we've prepped our model in SketchUp. How do we, turn it into something the physics simulation can understand?
Well, this is where the magic of code comes in.
Okay.
There's a Python package that we
Ooh.
can use that was made by a developer named Felix, and it does the heavy lifting.
Really?
It converts the SketchUp model into something that's ready for physics.
Wow.
Now, I know it sounds intimidating, but it's really just like a one-line command
One line.
in the terminal.
Oh, terminal.
I know it sounds scary, but it's much simpler than it seems.
I see.
The source material actually provides the exact command, so you can copy and paste it.
That's great.
Yeah.
All right, so we run that command, and what are we left with?
You'll have a .js file, which is essentially a text file containing all the 3D model data, just in a language that Easy JavaScript Modeling, or EJSS, understands.
So we've translated our model, we've got the instructions.
Get right.
What do we do with that?
Now we need to plug it all into a physics simulation. We add our JS file to an EJSS project and do a little tweaking in there. We'll tell it how we want it to behave within the simulation,
Right.
and then we save it and put it in the right folder.
Got it, like assembling the pieces.
Yeah.
But before we get too far into the really detailed steps, does this source material provide any examples of what this looks like in action?
Oh, absolutely. There's a link to a live simulation of a flight dynamics gimbal on iwanttostudy.org.
Cool.
It's the perfect way to see how all of this comes together.
Nice.
Yeah.
Well, before we move on, I think it's important to keep in mind the big picture here.
Sure.
Why is this whole process so important?
Mm.
Like, what are the implications of being able to create these 3D simulations?
That is an excellent question.
Yeah.
And the perfect segue into part 2.
Right.
We'll unpack the why behind this whole process and explore all the possibilities that it unlocks.
Can't wait.
Stay tuned.
Welcome back to our deep dive, all about making these interactive 3D models.
Okay.
And I think as we were saying before the break,
Taking a 3D model and kind of getting it to like dance to the tune of physics opens up so many cool possibilities.
yeah. And I think especially like the potential for education is just huge.
Oh, absolutely. Imagine like a classroom where instead of just reading about gravity, you can actually see it in action, right?
Yeah.
You could have students experimenting with different forces on an object in 3D, watching how it moves, how it reacts.
That's so cool. And,
Yeah.
the source actually provides a really cool example of this.
Oh, yeah.
The flight dynamics gimbal simulation on iwanttostudy.org.
Right.
I was playing with it earlier. It's so cool.
Awesome.
So like instead of just, reading about how a gimbal works,
Yeah.
you can actually like play with the 3D model and see how all the different parts move.
It's all about that learning by doing.
Yeah.
You get a much deeper understanding when you can interact with it.
Totally. It's like, the difference between reading a cookbook and actually getting in there and cooking.
Yeah.
Yeah.
Hands-on.
And the thing that's really cool about this is like, using these open source resources like EJSS,
Hmm.
it allows educators to create these really cool interactive
They're
experiences
free.
without, having to spend a ton of money.
Exactly.
It's just amazing.
Yeah, levels the playing field, makes learning more accessible for everyone.
For sure. And it's not even just for classrooms.
Right.
I mean, anyone with an interest in physics can use these tools, right?
Totally.
Students, hobbyists, even just like curious people.
Mm.
It's really cool.
No.
And when you think about it, the process that we outlined to do all of this is
Yeah.
really not that complicated.
It's not. It's really not.
There's a few steps, but,
A few steps,
the
but...
source material lays it out pretty clearly.
And with a little bit of guidance,
Yeah.
anyone can create their own physics simulations. It's amazing.
Like, it really sparks the imagination of, like, all the things that you could create with this.
Right. What could you simulate?
Yeah.
Basic mechanics, complex systems, I don't know.
I'm picturing, like, a virtual roller coaster where you can change the track and see how it affects the forces on the cars.
Yeah. And you don't have to be a coding wizard to do it either.
Right.
These tools are designed to be user-friendly.
It's so cool.
It really is.
Like having a physics lab at your fingertips.
Exactly.
And the fact that it's open source means it's constantly being improved upon by,
a whole community.
yeah, this global community of developers.
Exactly. And speaking of community,
Yeah.
before we move on to some of the finer details of like the actual conversion process,
Yeah.
I want to throw a question back out to you, the listener.
Okay.
What kind of 3D model would you bring to life in a physics simulation?
What are you curious about?
Yeah. Is there something from the natural world that fascinates you?
Like a bird in flight.
Yeah.
Mm.
Or maybe something mechanical, like a clockwork contraction.
Oh, cool.
Think about it.
Yeah.
Keep those ideas brewing as we delve into some additional tips and resources that can help you on your journey to becoming a 3D physics simulator extraordinaire.
I love that.
Stay tuned for the final part of our deep dive.
All right, welcome back to the final part of our deep dive. We're going to get into the nitty-gritty of actually making this happen.
Yeah, time to fine-tune our understanding.
Yeah, for sure.
Now, remember how we talked about aligning that 3D model's origin and x-axis
Yeah.
in SketchUp?
Yeah.
It
Yeah.
might seem like a small detail,
Right.
but it's actually crucial.
Oh, really?
Yeah.
What happens if we skip that step?
So SketchUp and Easy JavaScript Modeling, or EJSS,
Right.
they have different ways of looking at 3D space.
Okay.
So by aligning the origin and x-axis,
Right.
we're essentially like translating between their languages.
I see. So we're making sure they're on the same page
Exactly.
before we start telling them what to do.
Yeah, you got it.
Okay, cool. Any tips for making sure that we get this alignment right?
The blog post that's mentioned in the source material is really helpful for this.
Oh.
It actually has like visual step-by-step instructions.
Nice.
So you can really make sure that you're doing it correctly.
Perfect. I always love when there's visuals.
Yeah, me too.
Makes it so much easier to follow.
For sure.
Okay, before we move on, though, I do want to circle back to the Python script we were talking about.
Okay.
The fact that this was created by this individual, Felix,
Yeah.
it's pretty incredible.
It really speaks volumes about open source collaboration.
Right.
Someone with the expertise and the passion
Yeah.
decided to just put it out there for the world.
Right.
And suddenly this complex process becomes so much easier.
It's like amazing how one person can have such a huge impact.
Totally.
So cool. So for those of us who might be a little intimidated by the terminal or coding in general,
Yeah,
is this Python part really doable?
absolutely. The source material, it clearly outlines the commands you need.
Okay.
You literally just copy and paste them into the terminal.
Oh, okay. So no actual coding.
No complicated coding. Nope.
That's great. The magic of copy and paste
Really is.
saves the day again.
It does.
All right. So we run that script, we get our JS file, and we're ready to bring it all together in EJSS. What's next?
This is the grand finale.
Okay.
We take that JS file with all our 3D model data.
Right.
We add it to our EJSS project.
It's okay.
We can make some little tweaks to the JS file itself.
Like what kind of tweaks?
You can adjust its properties, like how it interacts with the physics engine, stuff like that.
Okay. I see.
Save it, put it in the right folder, and voila!
It's alive.
Exactly!
That's so cool. It's really amazing how it all comes together in the end.
It is. It's like watching all the pieces fall into place.
Well, before we wrap up completely,
Yeah.
I do want to come back to that question you posed earlier.
Oh, yeah.
What 3D model would you bring to life in a physics simulation?
I'm curious. Have you had any brainstorms?
Oh, I'm still thinking about it. There's so many possibilities.
Right.
Yeah.
Maybe you want to see a basketball bouncing,
Yeah.
or a pendulum swinging, or even something more ambitious,
Okay.
like a Rube Goldberg machine.
Whoa, that'd be crazy.
It would be amazing. And don't forget, the source material, they have that Flight Dynamics gimbal simulation.
Oh, right. Yeah.
That's a great starting
Oh, we
point.
can go check that out on iwanttostudy.org
Exactly.
for inspiration.
Yeah.
I love that.
It's a gateway to creativity.
Mm-hmm.
Who knows what amazing interactive simulations you'll create?
I'm excited to see what people come up with.
Me too.
Well, that brings us to the end of our deep dive into the world of 3D JavaScript and open source physics.
It's been a journey,
It really has.
but I hope it's been enlightening and empowering for everyone listening.
Yeah, for sure. And remember, never stop exploring and learning.
Absolutely. The world of physics is full of wonder and possibilities.
So true.
And with the help of open source tools,
Yeah.
it's more accessible than ever.
So go out there and create something amazing.
I can't wait to see what you come up with.